friends, thanks for watching. In this video, I would like to do a project with you where we will sort a sequence of numbers from smallest to largest. So you see on the screen I have an array of 4 numbers. So this is the sequence that I would like to sort. So sorting for us as humans can be easy, but for a computer it can be hard because you have to tell the computer step by step how to do the sorting. So we have to come up with a strategy. So here is the strategy that I propose. So let's tell the computer that the beginning number of the sequence right now, which is 90, is the minimum number of our sequence. So right now the computer will think that the minimum number of the sequence is 90, and the position of this minimum number is position 0. So it's a 0th position of our array. Then we will write a code that will compare the adjacent number. For example, right now it will compare 80 to 90 to see if 80 is smaller. So if it is smaller, then it becomes the new minimum. So in this case, 80 is smaller, so it becomes the new minimum. So then the code continues this to the next number, 40. Is 40 smaller than 80? Yes. Then 40 becomes the new minimum. Then again, we compare to 60. Is 60 smaller than 40? No. So 40 remains as the current minimum. Okay, so the code will say that the minimum number of our sequence is 40, and this minimum is in position 2. Okay, so now what? So now we have to swap 40 and 90. Okay, why? Well, because we want the actual minimum number to be the first number of our sequence. So we have to do the swap. So if you do the swap correctly, we should have 40 as the beginning number of the sequence, and then 90 will take its place. Okay, so we did the sort correctly so far because we have 40 as the first number, which is correct. But how do you sort the remaining 3 numbers? The strategy is you ignore 40 and you pretend that you have a new array now, an array of 80, 90, and 60, and then now you will sort this array. Okay, but at least as a beginning step for our code, can we at least sort our array to get to this step, get to 40, 80, 90, 60? Okay, so let's write the code. So the first thing we will do is create an array to store our 4 numbers. Okay, so our strategy says that we will assume that the minimum number is the number in the 0th position of our array. And so the position of the current minimum is 0. Okay, so now we have to write the code that will do the comparison of all the other numbers to see if we have an even smaller minimum, which will become the new minimum. So I will write the code that will do the comparison of all these numbers, and then I will explain what the code is doing. Okay, you see that I have written a for loop where count 2 has the value of 1, 2, 3. Okay, it always ends at 1 less than the upper limit. So count 2 starts at 1 and ends at 3. So what does count 2 represent? It represents the position of these 3 numbers, because these are the 3 numbers that we want to compare to the current minimum to see if they represent a new minimum. Okay, so what the code does is it says, for the number that you're looking at now, so for example, we will start at 80. Is it smaller than your current minimum? If it is, then the number that you're looking at now becomes the new minimum. And the position of the current number becomes the position of the minimum. So you will start with 80 compared to 90. Is it smaller than 90? Yes. So 80 becomes the new minimum and position 1 becomes a new position. Then you go to 40. Is 40 less than 80? Yes. So 40 becomes your new minimum. And the position of 40, which is position 2, becomes the new position of the minimum. So eventually, we should get that 40 is the actual minimum. Now we must go to this part where we do the swap. So how do we do the swap? Well, the strategy is this. First thing we must do is remove this 90. So we can't just move it somewhere, we have to store it. So we will store it in a variable that we call temp. Okay, so then what we do is we take the actual minimum, which is 40, and we will move it to position 0, which is where 90 used to be. And then the last step is we take 90 out of temp and we move it to 40's original position. Okay, so that is our strategy. And I will code that now. Okay, so I've done the code. So let me change this back. Okay, so in this code, I said let the number in position 0 be moved to temp. Okay, so the number that was here, 90, got moved to the variable temp. Okay, and then take what we know is the actual minimum and move it to 90's original position. So 40 gets moved to where 90 was. And then take the number that is in temp and move it to where 40 was. So now 90 gets moved to where 40 was. Okay, so that's how the code works. Okay, so now I will print out the array to see if we can get the right sequence. Okay, so we got 40, 80, 90, 60 as we desired. Okay, so how do we sort the rest of the array? Well, our strategy was that we will ignore 40 and let 80, 90, 60 become a new array. Okay, so it is a new array. But once you sort this array, so for example, here if you sort it correctly, 60 should swap with 80. And then, okay, you will have 90 here and 80 here, and you must sort that array too. So you have another array to sort. So what you notice is that you are repeating this whole process multiple times for multiple arrays, which already indicates to you that you will have to have a for loop. So what I will do is I will indent all of this code in order to prepare for a for loop. Okay, what you see is that we hard-coded 0. Why? Because For our very first loop, when we looked at just the original array, we said that the beginning number of the sequence will be assumed to be the minimum. So the beginning number of the sequence was 0. Okay, but for the next array, the beginning number is no longer 0, it's 1. And for the next array after that, the beginning number will be 2. So you can't hard code 0 anymore. Okay, so instead, we will let it be count 1. Count 1, I put range 0 to 3. That means that it will start at 0, it will go to 1, then it will go to 2, which corresponds with this. It starts at 0, it's our minimum. Then for this array in green, 1 is the new minimum. And for this other array, this last array here, position 2 is the minimum. So that's why I put 0, 3. So we will remove 0 and put in count 1. So this 0 also is replaced with count 1. Okay, so every 0 was replaced with count 1. And also, we hard-coded this 1 here. But you cannot hard-code that 1, because that 1 represented the very first number where you started the comparison. So for our original array, 80 was the very first number where we sought to see if there was a new minimum. But then, for example, for the next matrix of 3 numbers, we begin with position 2 now. So you cannot hard-code 1. So instead, I will put count 1 plus 1. So that way, the position that we start the comparison at keeps moving along. So now if I print, it should work. Okay, so now you see we were able to sort the whole array. Because it's not good practice to hard code numbers, I will remove this 4. Okay, because what if your array was longer? Because you see right now we have 4 numbers, but what if we had 10 numbers? So we should not hard code this 4. So you see that this 4 happens to be the same number of elements in our array. Well, in that case, you can do this. Okay, so this function len gives you the length of your array, which is just the number of items in your array, which is 4, so it matches up. Here is 3, which is 1 less than the length of our array. Okay, so now if I run the code, it should still work. Okay, you see it works. So now I can add even more numbers and the code should still work. Okay, so you see we were able to sort all of the numbers correctly. Okay everyone, that's it for this video. I hope you liked it, and if it's valuable to you, then please like, comment, and subscribe, and I'll see you in the next video. Thank you.